Hi, Spring fans. As you know, I love production. Production is the happiest place on earth. It's better than Disneyland. And if you haven't been, you should definitely go. For so many organizations today, production is Kubernetes. And in this talk, we're going to look at all the different ways that Spring Boot supports your move to production. Okay, so let's go to my second favorite place on the internet, start.spring.io. Here, we're going to build a brand new application to introduce some of the concepts related to Kubernetes. We're going to build a brand new application today. We're going to use the Maven and we're going to use Kotlin. We're going to call this the customer service. We're going to bring in support for reactive web programming, reactive SQL data access, H2, which is an in-memory embedded SQL database. We're going to use the Spring Boot Actuator. We'll use Spring Native, I think that's it. I think that'll do for now. So H2, RTBC, reactive web, Actuator, etc. Let's go ahead and hit generate. That'll give us a zip file that we can open up. All right, we have a brand new Kotlin application. We can open this up in our IDE. And our application is going to talk to a database. I'm going to create a class in Java 15 and later. I think you have a preview feature supporting something called records, which are now GA as of 16. Records are cool, but Kotlin supports them as something like a data class. So data class customer, val ID, and what I'm saying is I have a primary key and I have a name. Okay, so val at ID. Good. Now that's the basic entity. I want to provide a repository to work with that, to handle the tedious, soul-annihilatingly boring read, write, update, and delete data management lifecycle. So I'll use a Spring Data repository, which in turn provides methods supporting things like save all, count, delete, find by ID, etc. These are reactive types, mono and flux. These are types that are asynchronous, and they publish data. And now I want to write some data. I want to initialize the data in the database. So I'm going to create an initializer, and I'm going to implement this application runner bean. I need to initialize the schema. I'm going to use a feature in the new Spring Boot 2.5 release that supports initializing my reactive connection factory, the thing that connects to my data source. We had something like this for Spring Boot and traditional SQL data sources before, but now it's actually part of the reactive stack as well. So create table, customer, ID, serial, primary key, name varchar 255, not null. Okay. So there's my SQL file. There's my application. Good. So now I want to initialize this, and I'm going to write some data to the database. I'm going to inject into the constructor a reference to the repository that we've just created. So there's my customer repository. You know, this is a private field. I don't need it to be a public getter in my. I don't need it to be a public getter in my class. I'll do a private val repo, and then I'm going to initialize the application, and I'm going to create a sequence of names using a reactive stream literal. These are people that are on the Spring team. So Josh, Spencer, Stefan, Olga, Violetta, Dr. Sire, Yushin. So there's our sequence of names. Let's visit each name and turn it into a new customer. So I'll say customer. Now, of course, the ID is going to be set by the framework. So I want this to be mutable, and I want it to be null at the beginning. So I'll make it nullable as well. So here I can now say null and then name, and that gives me a sequence of customers. And now I want to visit each customer. I want to flat map each one of those and write it to the database. So I'll say repo.save it. Right? It is an implicit parameter in Kotlin for lambdas. I don't have to define the parameter name. So in this case, I'm saying map. You know, back here it would have been name. I could have done that, but why? If I know it's just going to be one parameter, I can just refer to it, and that's the same as what name would have been. Same thing here. It is a reference to the customer. So here's all the saved data. Now, what I've got here is a publisher of customer. Right? In Kotlin, you don't have to specify these types. They're redundant, but I can here, right? If I want to be very clear about it. And I used flat map to make sure that that's what I got. If I had done map, then what I would have had is a publisher of mono of customers. I would have had a reactive type wrapping a reactive type. I would have had a stream of reactive streams, which is not what I want, right? So I'm going to unpack that inner reactive type by using flat map, okay?
All right, now save. So this is a pipeline. I've defined how the data is going to flow from the strings to the customers to the database, and I've got now a stream. Now nothing is going to happen if I run this code as is. Nothing will happen. I need to actually act on it by subscribing. The trouble is that subscription is asynchronous, so there's no guarantee that this will happen before this, right? So, or rather, there's no guarantee that all of that will happen before this. This might happen, kick off and take a few milliseconds and might finish after printing of 2, right? So what I want to do is I want to force one thing to happen before the other. And you can do that using reactive APIs. You just need to use the operator. So here's the first step, which is write data, right? Data to the database. And then the second step is fetch all, right? So val all equals repository.find all. Now I'm going to say saved dot then many, passing in all, and then subscribe. And when I subscribe, instead of just calling the subscribe method, I'm going to print out the results. So I'll be able to see what's happening. All right, we've got a application that's writing data to the database. The last thing I want is a REST controller. So I can do a REST controller class customer REST controller, private val repo customer repository. And I'm going to create an endpoint here that gives me all the customer data. So let's restart this. Okay, there we are. There's our records. There's all 8 of us. It's worked. Now, are we ready for production? Certainly not. One of the things that we need to care about when we build services is observability. And one way you can do that is to support the Spring Boot Actuator, which are a set of managed HTTP endpoints that give you information about the state of the application. So I'm going to include all of the endpoints. They're otherwise locked down by default, which is as it should be, right? You don't want all the sensitive information about your service being out in the open. We want to enable the Kubernetes probes. We also want to show the details for the health endpoints, okay? So there we go. There's our endpoints. There's our data. So let's go ahead and start this. So there's our REST endpoint. That's working. Let's go to the Actuator. Now, our Actuator gives us all the beans that are available to us, all the objects and how they relate to each other, their references, their dependencies, where they live, in which class file, etc. And then we have the health endpoint. We'll get to that in a second. We have the info endpoint. The info endpoint is an endpoint that gives us an enumeration of information that we can use to identify the service. So imagine this. Imagine you've written your code, you've done git commit, you've done git push. It goes to the CI environment. It creates a new build and it gets pushed into production. That is, after all, basically what continuous delivery looks like, right? So every git commit should ideally result in a push to production. It becomes very important then, if you're pushing to production possibly hundreds of times a day, to be able to correlate what version of software is running in production. So this endpoint is where you put that identifying information. You can do that here. You can say, I want to use info.message equals hello world, right? I can have a message there and that'll show up there. I can also customize it through the build. And one particularly interesting way to do that is to use the git commit ID plugin. So commit ID plugin. I'm going to go back down to the bottom here. And that git commit ID plugin will, on compilation, create a file called git.properties for any git repository. So I'm going to make this a git repository. Git add. Okay, minus am YOLO. Then we're going to build the file. So minus d skip tests, clean package. And that's going to create a text file here in the target directory called git.properties. So git.properties has the commit ID, the message, the username, email, the branch, all that kind of stuff that describes the current code. That will be incorporated into the actual info endpoint when you restart the service. So let's go ahead and do that. So there we are. There's my message, hello world. There's the git branch and the commit ID and so on. So now I have a way to say, oh, well, this service is running that version of the code. We also have the conditions endpoint, which gives you information about what conditions were activated when the application starts up. We have the config props endpoint, which shows you all the properties to which your currently configured Spring application will respond. We also have the environment. So this is great if you're trying to debug what environment variables are in. We've also got the loggers endpoint, which tells you which loggers are in play. And you can actually send a post to, for for example, change the verbosity of a particular log level. So if I open this up, you can see we've got, for this log level, for this package, it's considered info, and so on. You can override that, of course. We have heap dump and thread dump. They do what you'd expect. They give you a heap dump that you can plug into your profiler and a thread dump. We also have the metrics endpoint. And now this endpoint represents keys and values about your application. There's a bunch of them that are here out of the box, but you can actually pull in a bunch of others as well. One of those metrics that you get, for example, is the HTTP server requests. And there, if you go to the details, you can see there's actually different dimensions of that metric, statistics about that metric. So how much time it took, the max, and different ways of drilling down into the data. You can actually ask to see the HTTP server requests where the exception was a particular exception, where the method was a particular verb, and where the URI was a particular URI. And so this is great for seeing the multiple dimensions of this data. Metrics are great for low cardinality data. They're an aggregate value. They're a statistic. They're not meant to show you the details of any one request. They're meant to show you the statistics of all the requests, the trends, the big picture of all the requests. You can use that data in tandem with high cardinality data like distributed tracing to then follow up and say, okay, I've noticed that so many users have been hitting this endpoint and they got an exception. Then you can pivot over to the trace data using Spring Cloud Sleuth and something like OpenZipkin or Google Cloud Stackdriver Trace or Azure Spring Cloud tracing support, VMware Wavefront's tracing support. You can use those different tools to then drill down into the details of one particular user's request. And you can see, okay, well, we know that some people have this error. Let's look for that error in the trace and then see what happened and see their movement through the system, maybe find the root cause, right? This is a great thing to do for any system, but I think it's just important to understand how easy this is. This Actuator endpoint is powered in turn by something called Micrometer. Now, Micrometer is a vendor-neutral application metrics facade. It provides a way to talk to different time series databases like AppOptics, like Prometheus, which is very common in Kubernetes, like VMware's Wavefront, Google Cloud Stackdriver, Azure Monitor, Graphite, Dynatrace, all these different things, right? It's all supported out of the box, and you can do a lot more than just view the data here as a REST endpoint. We also have the scheduled tasks, which shows you which tasks are scheduled to run as sort of a cron job. And we have the mappings, which shows you which endpoints are available to you, which endpoints are mapped to what control handlers. So here we have the actuator endpoints themselves are provided by this class. They respond to this HTTP verb. They produce this content type, etc. Right? Very, very convenient. Now you can see what the surface area of your HTTP application is. So we like the actuator endpoints, but let's return to the health endpoint. The health endpoint gives me an enumeration of the different subsystems in the application that, were they to fail, would imperil the health of the overall service. So the status is up for all of them. But for any particular component, the file system, the liveness, the readiness, the connection factory, we can also see a status as well. So here, if my database is up, I'll see that reflected here. If my disk space is up, I'll see that reflected here, etc. We have here in the health endpoint two Kubernetes specific bits. These are called probes. We've got the liveness probe and the readiness probe. The readiness probe is evaluated by Kubernetes when the application starts up in order to determine whether the service is ready to be put into production. The liveness probe tells Kubernetes whether the service is still fit to stay in production or if it should be, if the pod should be killed, right? Now that we understand what those probes do, let's create a controller so we can demonstrate signaling that the service is sick. Okay, so we're going to create a REST controller, class availability controller, fun down, availability change event publish, and we're going to use a pointer to the injected application context. Okay, post mapping down. What? Okay, this.ac. We're going to do a liveness state, and we're going to publish an application context event to the components in the application context, one of which will be the health indicator and the probes. So now let's check the liveness of the service. It's up. Let's send a post to knock it down. It's down. And let's check the liveness again. Now you can see this state is down. So the service has a way of communicating to Kubernetes that the service is not okay. And if we look at the detailed output there, you can see we got a 503 service unavailable, whereas before we would have gotten a 200 series status code. All right, so now what happens when Kubernetes sees that our service is down? Well, it's going to try and decommission the pod. It'll take it out of production. it's going to have to shut down the pod. It'll send a sig term and then it'll sig kill. But the thing is, that can be a little violent if you've got things that are already in flight, already running. We want to be able to taper off any existing in-flight transactions, and we want to stop accepting new transactions. So here we can take a look at graceful shutdown, right? So instead of doing immediate shutdown, we can use graceful shutdown. Graceful shutdown stops any new requests and lets the in-flight transactions finish their work. You might have to wait a little while though. You want to wait maybe 30 seconds, right? You need to also configure the equivalent setting in your Kubernetes pod description, of course, as well. Now, we've got our service, we've got a number of different endpoints, we've looked at Kubernetes liveness and readiness probes, we've got configuration here in the config file. Now this configuration is all just sort of jumbled together, and obviously one very common pattern is to create another file and then suffix it with the name of a profile. And that profile might only activate in the environment in which you intend to run. So you might have a cloud profile, and that might be what you activate when you run the code in Kubernetes. In Spring Boot, we can now support sort of different sets of configuration in the same property file. We've always been able to do that for YAML because it was built in, but we've added support for that in property files now as well. I can create a new section of configuration, hash and then 3 dashes. And here I can create an activation trigger. So I can say activate on profile cloud, and then everything after this and in between this will be run only when that profile is active. And so I can actually put things like, for example, the probes, I want that only when I'm running inside of Kubernetes, right? And maybe I want this, the graceful shutdown and all that stuff, only inside of Kubernetes. And being able to activate something based on a profile is very useful. You can, of course, do this in your code as well. So you can actually have this, let's say I have this availability controller. I only want this controller to be available when I'm in the cloud profile, right? And so this bean doesn't exist. You're actually carrying a separate branch of your runtime, and that's not exactly a great pattern, so I don't encourage you to do it a lot. But you can if you need to. The other thing that you can do is to activate based on a cloud environment, right? So here, rather than using a profile, you can just say, hey, well, let's just split the difference. How about I just activate this when I'm in a Kubernetes environment, for example, and you can just assume that's important. I showed you how to use a profile to conditionally create a bean, but you can also do the same thing with a cloud platform. So you can say Kubernetes, and this bean will only be accessible when you're running inside of Kubernetes. How convenient, huh? So you have an analog in the configuration as well as in the Java code, add profile or add conditional on cloud platform. Okay, so we've got this on cloud platform equals Kubernetes. This is going to automatically be set to true when you're running inside of a Kubernetes. But if you want to kind of test what happens, you can actually set a property. You can say cloud platform equals, and then you can choose Azure, Spring Cloud, Cloud Foundry, Heroku, SAP, or Kubernetes, right? I'm going to customize the program arguments. So I'll say -- Spring main cloud platform equals Kubernetes. Hit apply, hit OK. And now this is going to run as though it's inside of Kubernetes. And so in order to prove it, let's customize that info endpoint to say, hello, Kubernetes. So the applications have been running. Let's go check. We'll go to the Actuator info endpoint, and you can see it says hello Kubernetes. So again, this is only because it thinks we're running inside of a Kubernetes environment. This is very convenient, right? We can have bifurcated sets of configuration. You might do this for all sorts of reasons, right? You might just have to change ports. It might just be that you have a different data source. But of course, if you're connecting to a data source and you want to specify the username and password, that's not something you should store in the version-controlled source code for your application to have properties. Instead, that typically lives external to your application in a config map or a secret or something like that in a Kubernetes environment. You might use something like HashiCorp Vault. You might use Azure Spring Cloud's secrets management. You might use the Spring Cloud config server. There's a lot of different places where you could store your config. In Kubernetes, it's very typical to want to store that in a config map and in a config secret. You can expose the config map to your application as either an environment or as a config tree, a directory full of configuration. If you expose it as an environment, then that will just work automatically, right? So anything that you put in the config map is automatically visible to your Spring Boot application. And Spring Boot goes even a step further. Did you know that if you run the application like this, if you say export server _port equals 8010, that will automatically get mapped to the property in Spring Boot called server.port, right? And so you'll end up overwriting what would have been specified in application.properties, right? So if you specified port equals 8010 in your property file, or 8020 in this case, and then did 8010 there, 8010 would win, right? So that heuristic of taking your properties, underscoring them, and capitalizing them, that works great. But if you use the config map as a config tree, well, then Spring Boot has good support for that as well. You can actually import those config trees as configuration. A config tree in Kubernetes is a directory full of configuration whose files are named after the properties that are being configured and whose values, whose contents are the values of those configuration properties. So I want to activate some configuration in my config tree. I can do that. I can say spring config import, but I want to do a config tree. I'm going to point it to my home directory, desktop, and I'm going to point it to the config directory. Okay, now I'm going to create that directory over here. Make dir desktop config. I've got the directory now that's been created in my local machine. I'm going to go to the desktop and specify the config. I'll say echo 8050 to a file called server.port. So cat server port equals 8050. And in my application, I've specified that we should load that config tree when the application starts up. So even though the default is to run in port 8080, right? And I'll make it explicit here. Even though that's the default, I'm going to load the configuration in the config tree, and that should take precedence. Okay, so there it is, port 8050. It's worked, or our applications have been running on a new port. Okay, so there we go. There's our new service running on that port. And that's only when we're running inside of Kubernetes. If I get rid of this, if I go back here, get rid of that, hit apply, hit OK, restart. You can see the application starts up again on port 8080. Okay, I think we're ready. I think we've got everything we need here. We want to be able to deploy this to a Kubernetes environment. Obviously, in Kubernetes, you need a Docker image. And don't freak out. We don't have to create Docker files or write YAML. YAML is one of the reasons that people leave IT. I'm not a fan. Let's not get into that. Instead, we're going to use something called build packs. Now, build packs are a specification that are part of the Cloud Native Computing Foundation. They are a way to take a application source code artifact and turn it into a container image, an OCI image that you can run on any cloud. There's an implementation called Paketo, and Paketo it's an implementation of build packs. Now, build packs, of course, originated as part of the work that Heroku was doing. The Spring team and the Cloud Foundry team at Pivotal years ago embraced that approach, and we expanded upon it. And the two of us, Heroku and Cloud Foundry, we got together and donated our work to the Cloud Native Computing Foundation. So this is a very useful thing that has been around for years and years and years. And it's hopefully one of those things you don't even have to know about most of the time. You can just put it in your CI pipeline, and then it just automatically takes care of taking your jar and turning it into a container. The core conceit of build packs is that there are only so many different ways to take an application and turn it into a Docker image. Why bother reinventing that particular wheel? We can use these build packs easily. Let's go back to our application. We could use the pack CLI if we wanted to manually, but Spring Boot has that supported out of the box. So I can do maven clean Spring Boot :build image, and that'll actually build the image for me. Now, when I created this application, when I created this application at the Spring Initializer, I made sure to include Spring Native. So while I would normally, if I hadn't selected that, normally I would just get a Docker image that contains a JRE and it contains my Spring Boot application. Spring Native will let us use GraalVM's native image builder. Now, GraalVM is an open JDK distribution that has a few extra accessories, a few extra optional components. It's super convenient. One of the components that it has is something called the native image builder. And the native image builder does static analysis of your application at compile time, and it throws away everything that's not being used directly. Everything that it can determine statically is being used. It keeps everything else it chucks. And that includes the very large majority of any runtime that you might have had. So the JRE goes away basically, except for the code that's being used directly by your code, and all the other stuff on the class path in your application that isn't being used. It then takes whatever's left and turns that into a native architecture-specific binary, so a Mac or Linux or Windows-specific binary. Super useful for two reasons. The resulting binary is very small. We're talking about tens of megabytes in terms of file size. And of course, in memory footprint, it takes tens of megabytes of RAM to run the application. And then the other reason is that it also starts up very quickly. It'll start up in the order of, milliseconds, not seconds or hours or anything like that. So it's very, very quick, right? I prefer them mostly because I care about that RAM footprint. That memory footprint can be very useful. It's a great opportunity. But there's a lot of work that has to be done to make this happen because, like I said, it does static analysis. It's very eagerly throwing away everything about your application that it doesn't know about. So you have to give it configuration in the form of JSON files that tell it where you're going to do something that it doesn't know about. Any of the dynamic behavior that makes Java so fun and so much more productive than, say, for example, C++, it doesn't know about. So for example, reflection, serialization, proxies, JNI, right? All these kinds of things are all part and parcel of the Java experience. And they're one of the reasons that Java has become, it has very effectively sort of straddled the line between a scripting language or Smalltalk or something like that with a more dynamic flavor to it and systems languages like C and C++, because it's got a very dynamic runtime, but it's also got this very sort of rigid type system. Well, rigid-ish. It's not the most rigid, certainly. So you need to preserve some of that, and you can actually do that. If you provide config files, GraalVM will make it so that those things still work, but you have to explicitly tell about that. Spring Native is an AOT framework. It analyzes your code in your Spring Boot app, and it provides those hints for you on your behalf to the GraalVM compiler. So it knows about most of the tricks that typical Spring applications will do, and it provides all that configuration. And more to the point, we're also writing integrations for all the stuff that we can think of in the third-party ecosystem. So for example, Apache Tomcat. Everybody uses Apache Tomcat. We had to make that work with GraalVM, Netty, and other databases, and Apache Kafka, and all these kinds of things that you're going to use with your Spring application. We've also been working to support. So all that is easy. We didn't have to change anything in the code. We just have to plug it in. Then we ran the build pack, and it's going to run in the background and create a native image for us, right? That build pack normally takes, 30 seconds to create a JVM application. But because of what GraalVM is doing, because we're using the native image compatible build pack, it's actually going to compile everything. And that means it's going to compile all the .class files in the entire application, and all the jars and the entire class path, and our .java files. It's not just compiling the .java file. So it takes several minutes. It can take 5-6 minutes to get this done. All right, our application is built. Let's go ahead and run this. We're going to do docker run -p 8080 :8080. And there we are. There's our application. It starts up in about almost 2/10 of a second, which is fine. It's very, very fast. It's much faster than by default. This application would have started up in about a second, maybe 1.1 seconds on the JVM. And more to the point, I'm also streaming, so keep that in mind. I'm running a bunch of screen capture software to record this video and to record my voice and all that. So it's pegging the CPU. But much more usefully, much more importantly, the footprint is much less, right? So the application will take up tens of megabytes of RAM, not hundreds or something north of that. So the application is certainly ready for production. We have a Docker image now. We can Docker tag that and then Docker publish it to our container registry. We could use something like Docker Hub or Google Container Registry or VMware's own VMware Harbor. Either way, you're ready to now include this and reference it from your Kubernetes pod deployments.
And so with that, we've looked at how to build applications that are destined for production with Kubernetes. I hope you got something out of it, and as always, I hope you're happy, healthy, and well.